Hello, Chem 111. This video is about writing electron configurations for atoms, and I'm going to teach you the most efficient way to do it, which is using the periodic table. But we'll start out with an energy level diagram. And when I say electron configurations, I should put a little asterisk there, because what I mean is the ground state or lowest energy electron configuration. And sometimes people don't say that, and that's what they mean when they say write an electron configuration, because we have rules about where the electrons should go, and it's based on creating the lowest total energy for all the electrons. So let's start with carbon, which has atomic number 6, and I've drawn here an atomic energy level diagram. I stopped at 4p because I got tired. And here's how we would put the electrons in. So when the atomic number is 6, just to remind you, that means you have 6 electrons. So we start with 1s and put in an electron, and then we put in a second electron pointing the other way, which means it has opposite spin to the first one. So that's 2. Then we put in 3 and 4. Now we have 2 more electrons, and so we're going to put them up in the 2p, and we're going to put them in separate orbitals first. And that's where we stop for carbon. It only has 6, and I just arbitrarily put them in the second and third p orbitals because they can go in any of those 3, but they have to be in separate ones, and they have to be pointing the same way. And I drew them down just to point out that up and down don't really mean anything. What is meaningful is that both those electrons are pointing the same way. So that's how I would put electrons in the energy level diagram. To write the electron configuration, I then write it as 1s2, 2s2, 2p2. And that's how I read it. I say 1s2, 2s2, 2p2. I don't say 1s squared, 2s squared, even though it sort of looks like that. It's a superscript. And that's the electron configuration for carbon. So now if we wanted to do phosphorus, that has an atomic number of 15, we have to do 15 electrons. The first 6 are going to go in just like carbon, so I'll start with the 7th electron, and it would have to go the same direction in the remaining empty orbital. That gets us to 7, and then 8, 9, 10. I'm putting them in arbitrary order, not left to right, just to really highlight that we don't really know where they are in the 2p, just that they go in an empty slot. All right, so now, what did I say? We're up to 10, and then 11, 12, 13, 14, 15. So if I want to write the electron configuration for phosphorus, again, I start at the bottom. It's 1s2, 2s2, 2p6, 3s2, and I'm running out of room, but I would write it in the same line normally, 3p3. That's the electron configuration for phosphorus. If I need to add 5 more electrons to get to calcium, I can add these 3. So I'm at 16, 17, 18. And then here, it's hard to tell on this diagram, and that's intentional, but the 4s is, in this case, lower energy than the 3d. And so, in fact, the next 2 electrons go here, not in the 3d. So the electron configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. All right, so that's how you write an electron configuration from putting electrons in an electron energy level diagram. All right, so now if I said to you, I want you to do molybdenum, which is atomic number 42, you're going to need a lot more energy levels, and it gets pretty hard to tell. How did I know the 4s is lower than the 3d? And then I have the 4p. What about the 5s and the 4d? And then I'm going to have a 4f. So this is why we use the periodic table. So I'll go to the next page and show you a periodic table level diagram to see that, the D block actually starts at 3. So the periodic table, in fact, its whole purpose in life is to arrange elements by their electron configuration. So if we look at the periodic table, it's very helpful to understand that this here is the S block, This over here is the P block. I'm just going to point out that helium really is in the S block, even though for other reasons it's over here. In the middle here is the D block. And then down here at the bottom is the F block. And if we had more elements, eventually we'd have like a G block somewhere, but they haven't been discovered, so we're good. And then we can think of the rows as numbered, 1, 2, 3, 4, 5, 6, 7. We do have to look back for a second. And so if you look, the D block starts in this row here, which, it's row 4 here, but this is actually the first row here is the 3D. So the D block lags behind by 1. Similarly, this is 4F and this is 5F. And you can see the F block comes in here. So that would be 3D here, 4D, 5D, 4F. So D lags behind P, F lags behind D. That's really the only tricky part. So now I just want to show you how to do the electron configurations I just did without drawing that energy level diagram. So we'll go back. Let's try carbon, which is atomic number 6. And what I do is count up by atomic number. So I start with hydrogen here. So hydrogen here is 1s, 1, and then I'm still in the S block for helium, so I call that 1s2. So if I'm writing carbon, I count up 1s2, and that took me here to atomic number 2. Then I go to 3, and if I look at 3 here, it's back in the S block, but it's row 2. So I just read off 2s2, 2s1, 2s2. So 2s2, I'm not to carbon yet. I hop over here. Now I'm in the P block. I'm still in row 2, so I say 2p1, 2p2. And I'm done because I got to carbon. Let's try another example. Let's try phosphorus, which we also did before, number 15. Phosphorus is equal to, again, I'm going to start here, 1s1, 1s2, so I'll write that down, 2s1, 2s2, 2p1, 2, 3, 4, 5, 6, 2p6. Now I go over here and back in the S, now I'm at 3s, 3s1, 3s2, hop across to this P block here, so it's 3, 3p1, 2, 3, and I'm done. That's phosphorus. Now, before I give you a couple problems to try, I want to point something out. So phosphorus is 15. It's not too bad. You saw when we did calcium, it got kind of long. There's one shortcut we do, which is called the noble gas shorthand. So the noble gas shorthand says, go backwards to the last noble gas, and the noble gases are this last column here. Go back to the last noble gas that you filled before you got to the element you're doing. And in this case, the last noble gas is neon, number 10, right? That's the last one we passed on the way to phosphorus. And neon is 1s2, 2s2, 2p6, and fills up the 2p block. So we can rewrite phosphorus as this part is just neon, and so we write neon in square brackets, and then we write the rest, 3s2, 3p3. So that's the way we tend to write for bigger elements in particular. We use noble gas shorthand. All right, so I'm going to give you a couple other ones to try. I'm going to erase this stuff and ask you to try a couple other elements. So let's try Let's try selenium, and let's try indium, IN. Those are two fun ones. All right, so you can pause the video now. You can write these with noble gas shorthand and give them a try, and then start the video again when you're ready to see the answer. And I'm going to go ahead and erase all the little marks I made on this. Okay, so if we start with selenium, selenium is here. And so the last noble gas that I filled is argon. So I'm going to go ahead and start with argon. And then I have to just, so argon's number 18. I start with 19. So 19 is over here. And that is in the S block, and it's the fourth row. So I say argon 4s2, 1, 2. And now 21 is the next element, so I have to march through the D block. And this is where I have to remember that D lags behind by 1, so it's 3. So I write 3D, and then I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 3D, 10. And now I'm back at 4, 4P. 1, 2, 3, 4. 4P, 4. So that is the configuration for selenium. Okay, if we look at indium, use pink for this one. Indium is here, number 49. Its last noble gas is krypton, number 36. So I'd write krypton in brackets. Then I go to 37, which is over here again in the S block. It's in row 5, so it's krypton 5s, 1, 2. And now I'm in the D block. Now I'm in 4D. It lags by 1, so I'd say 4D. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And back to 5P, and it's just 1. 5P1. So that's indium. All right, I'm going to give you one more to do. Which again, you can pause the video and try. And I'm going to give you one that makes you march through the F block. And again, the important thing to remember here is that the F block is inserted here at lanthanum. Now, if you get to actual lanthanum, there's an interesting question about 5D versus 4F, but I'm going to give you something where you just march through the whole F block. So we're going to try bismuth, which is number 83. And just you have to go up through the atomic numbers. So why don't you see what you get for that one? And then you can come back and see what my answer is. Okay, so we're ready to try bismuth. I'm going to do it in green. So bismuth is number 83. And go all the way back to xenon here at number 54. So xenon, and then we go up to 55, which is over here. That's S, and it's 6S. I'm looking over here at my numbers. You can just count down 1, 2, 3, 4, 5, 6. So xenon, 6S, 1, 2. And now, lanthanum sits here in the D block, right? It would be 3D, 4D, 5D. But I'm going to go from there right away down to the 4F. And bismuth is 83, so I'm going to have to march all the way through the 4F. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So I'm going to go ahead and write it this way, 4F 14. And then I'm going to go back, pick up lanthanum was 5D1. And then to get to bismuth, though, I have to go all the way through. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 5D10. In bismuth, I'm back at 6P, 1, 2, 3. And so I want to just sort of emphasize this lanthanum piece. It's almost like you did, 6S2, 5D1, and then 4F14, and then you came back and did the last 9 of the 5D. But we just put those two together, so you get 5D10 there. And that's how you use the periodic table to write electron configurations.